Hello, in this video we'll learn about linear discriminant analysis LDA with a solved example. So first we'll learn what is LDA, linear discriminant analysis. LDA is a supervised classification technique which is used to distinguish between two or more classes. Actually, this reduces a high dimensional data into lower dimensional data space, and this LDA is used to identify a linear combination of features which actually best separates the classes within a given data set. Consider this example. Here we have taken two different classes that needed to be separated. Okay. In these two classes, each class will have multiple features. For example, class 1 will have 5 features. Similarly, class 2 will also have 5 features to classify these two classes. And consider out of these 5 features, when we use only a single feature to classify this, there may be overlapping. So this shows the overlapping. To address this problem, we go for LDA. Here, LDA uses multiple features to improve the classification accuracy. We look into the assumptions of LDA. LDA actually assumes certain things to perform its execution. The first one is the Gaussian distribution. It means that the data in each class, consider the data in one particular class C1 or either C2, should be in a Gaussian distribution manner. The second one is equal covariance matrices. It means that all classes should have the same covariance structure. The next one is linear separability. The data should be linearly separable using a straight line or a plane or a hyperplane. So in this case, even though there is a misclassification, you can see there is a straight line which separates two different classes. Following these assumptions, LDA works. LDA will perform effectively based on the assumptions whatever we have seen. For example, when data points belonging to two classes are plotted, in this case we are using scattered plot. If they are not linearly separable, LDA will try to find a projection which maximizes the between class separability. We'll see this. So see here, even though there is a misclassification, you have a straight line, okay, which linearly separates two classes. Now LDA tries to find a new axis which maximizes the distance between these two classes, as well as it tries to minimize the within class variance. So how it is done? It tries to build up a new axis, and here the perpendicular distance from the decision boundary, this is the decision boundary. So the perpendicular distance from the decision boundary to the data point shows how the LDA reduces the within class variation and increases the class separability. Okay. Then these data points will be then projected onto a new axis as shown here. Here you can see a new axis have been created and the data points are projected onto the new axis. When you see here, it tries to minimize the variation within each class. You can see here, it tries to minimize the variation within the same class. Here also it tries to minimize the variation within this class, as well as it tries to maximize the distance between the two classes. Now we'll look into the LDA algorithm. The first step is to calculate the mean vectors for each class. The second step is it computes the variance of each class. The third one is it computes the within class scatter matrix. And then the fourth one is it computes the between class scatter matrix. The fifth step is find eigenvalues and we need to choose the top eigenvalue. Based on the top eigenvalue, we will be finding the eigenvectors. So based on the eigenvector, we will be finding out the new axis. By using the maximum eigenvector, this leads to a good separability between the two classes. We will see these concepts with an example. Consider we have a data set where we have 10 data points and these data points are separated into two classes, class 1 and class 2. So each data point will have two features, x1 and x2. Here the first data point is 4, 2. 4 is the first feature, 2 is the second feature. The next data point is 2, 4. 2 is the first feature, 4 is the second feature, and so on. So here also in class 2 we have 5 data points. These data points are plotted in a graph. The first step is to calculate the mean vectors for each class. We are selecting the data points for each class and then we are finding the mean vectors. What is the formula to find the mean? Mu1. 1 represents the first class, C1. Mu1 equal to 1 by n1 summation of x. X belongs to all the data points. So here we have 5 data points in class 1. So it is 1 by 5. Then the first data point is 4, 2. It is 4, 2 plus 2, 4 and so on. We are writing in this way. And how to find the mean? It is like 4 plus 2 plus 2 plus 3 plus 4 divided by 5. It is 15 by 5 which gives you 3. Similarly, we need to find the mean for the second feature. That is 2 plus 4 plus 3 plus 6 plus 4 divided by 5 which is equal to 3.8. Similarly, we find the mean vector for the second class and it is mu2. Mu2 is equal to 1 by 5. We have 5 data points and then the first data point in class 2 is 9, 10. So it is 9, 10 and so on. Then we find the mean vector. It is 9 plus 6 plus 9 plus 8 plus 10 divided by 5 which is equal to 8.4. The next one is 10 plus 8 plus 5 plus 7 plus 8 divided by 5 which is equal to 7.6. So these are the two mean vectors. The next step is we need to compute the variance of each class. So the formula to compute the variance for each class is Sk, where k is the number of class. Here we have two classes. K can be 1 and 2 which is equal to 1 by nk minus 1 summation of for number of classes we need to do x minus mu k into x minus mu k transpose. So for the first class we are going to find the covariance value. So how to find the covariance value? We'll look into it. So C1, this is the data, these are all the data points and then we need to find S1. So to find S1, first we will be finding what is x minus mu1 into x minus mu1 transpose. We need to find this. So what is the first data point? First data point is 4, 2. 4, 2. We need to find what is x minus mu1. What is mu1? Mu1 is 3 and 3.8. So we are going to subtract x minus mu1. So x is 4 and 2. Mu1 is 3 and 3.8. So it is 4 minus 3, 2 minus 3.8. We will be getting 1 minus 1.8. We will be getting this. This is actually x minus mu1. And we need to multiply this x minus mu1 into x minus mu1 transpose. So we need to multiply, this is x minus mu1 into x minus mu1 transpose. So how we will write it as 1 minus 1.8. So this is actually 2 by 1. The matrix size is 2 by 1 and this matrix size is 1 by 2. When we multiply these two matrices, we will get the matrix in the form of 2 by 2. So this is the matrix whatever we are getting. And when we simplify this matrix, we will get this matrix. Similarly, we need to do for the second data point 2, 4. So 2 is x and mu1, 2 and 4 are x, and mu1 is 3 and minus 3.8. We need to do a subtraction of it. So we will get x minus mu1. So this is x minus mu1. Then you take the transpose of minus 1, 0.2, and then we multiply both. We will be getting this matrix, and by simplification we will be getting this. So similarly, we will be doing for all other data points. Here it is given. You can work out and you can check it out. After doing this, we need to do the summation. So here summation of x minus mu1 into x minus mu1 transpose. So how to get the summation of it? It is for 1, 1 position, it is 1 plus 1 plus 1 plus 0 plus 1. So it is given here 1 plus 1 plus 1 plus 0 plus 1. So this is in the 1, 1 position. Then in the 1, 2 position, what we need to do? In 1, 2 position, whatever values we have, we need to add up. Minus 1.8, minus 0.2, 0.8 plus 0 plus 0.2. So we will get this one. Similarly, you do for 1, 2, 1 and 2, 2. So you will get this answer. Now we need to do the 1 by n minus 1. 1 by n minus 1. So it is totally we have 5 data points. 5 minus 1 is 4. So 1 by 4 into S total. What is S total? This matrix. Okay. So this is the matrix. So we get S1 as 4 divided by 4 minus 1 divided by 4 and so on. So this is S1. Similarly, we need to find S2. So how to compute S2? This is how we will be computing S2. The same method you need to follow to compute S2, and we get S2. With this, the second step is over. The next one is the third step. Here we need to compute the within class scatter matrix. So what is the formula to find the within class scatter matrix? SW is equal to S1 plus S2, which is equal to, this is S1 as well as this is S2. We need to add these two and we will be getting SW. This is SW matrix. Then we need to find between class scatter matrix. So what is between class scatter matrix? How to find? This is the formula. Yes, B in the sense between class scatter matrix is equal to mu1 minus mu2 into mu1 minus mu2 transpose. So this is mu1, this is mu2, 8 minus 4, 7, 8.4, 7.6 is mu2 into then into, you need to take the transpose of the same. So we will get 3 minus 8.4, we will get minus 5.4, then 3.8 minus 7.6 we get minus 3.8. We need to take the transpose of this. So when you get the transpose of it, we will be getting this way. Okay. So it is 2 by 1 and 1 by 2 matrix. So we will be getting the matrix in the form of 2 by 2. So this is said to be SB. The next one is we need to find the eigenvalues and choose top eigenvalue. Okay. So to find this, you know how to compute the eigenvalue. So this is the formula to compute the eigenvalue. SW inverse SB into W equal to lambda W. So first we need to find when we equate this, we will be getting this formula. The determinant of SW inverse SB minus lambda I equal to 0. Okay. Now we need to solve this. So we know what is SW. This is SW and we will be taking the inverse of it. And then SB. This is SB minus lambda into I. I is identity matrix. So this is the identity matrix. 1, 0, 0, 1 for 2 by 2, which is equal to 0. Okay, now we need to find the inverse. So in mathematics you might have learnt how to compute the inverse for a given matrix. So you can use a calculator or you can do manually to find the inverse matrix. Then multiplied by the SB matrix minus lambda into identity matrix. So we need to first multiply these two contents. So you will be getting the answer this way, minus lambda into identity matrix. So what is the lambda into identity matrix? So we will get lambda 0 and then lambda into 0 0, then lambda into 1 is lambda. Okay, so we will be performing a minus for this matrix. So we will be getting these values. Okay, and we need to solve the determinant. You know how to solve the determinant. So this is 1 1, this is 1 2, this is 2 1 and 2 2. So how to find the determinant of a matrix? In this case it is 1 1 into 2 2 minus 1 2 into 2 1. Okay, so this is how we will be finding the determinant. So that's how we get this equation, and which is equal to 0. Okay, and now we need to solve this equation. So we will get a quadratic equation. You can solve the quadratic equation. When we solve the quadratic equation, lambda 1 you get as 0 and lambda 2 is 12.2007. These are all the eigenvalues. From these eigenvalues, usually we will be selecting the maximum lambda value. So which one is having the maximum lambda value? It is 12.2007. Now we will check for both the values, lambda 1 as well as lambda 2. So we need to find the eigenvectors. So how to find the eigenvectors? We substitute the lambda value in this equation. We have already seen this equation. In this equation we will be substituting the lambda value. So it is first we have already computed SW inverse into SB. Here it is. So this value, okay, into W1 equal to 0. The lambda 1 value is 0. So we substitute 0 and W vector will be, we have two values, W1 and W2. And similarly when we substitute lambda 2, it will be here, it will be W2. This is the lambda 2 value and then W vector. So we have this W vector. When we solve these equations, we will get W1 as this value and W2 as this value. We will select only W2 because lambda 2 is having the maximum value. So W2 will be selected and we need to, using this W2, we will be constructing the graph. For example, if you are using the smallest eigenvalue to find the projection vector, then we will get a straight line similar to this. This is not dependent for any of the values given or any of the data points. And here also it gives you the bad separation. You can see this is a bad separation. Okay, here you can see all the data points are mingled together and you cannot separate the data points. And when we are using the highest eigenvalue, this is the new projection whatever we are getting. And whenever we find the LDA projection, this is the LDA projection. So here you can see the within class variation is very minimum. Okay, the within class variation is very minimum, whereas the between class variation is very high. The between class variation is very high, and so it is linearly separable data, as well as you can see the data are in the form of bell-shaped curve, that is a Gaussian distribution data. Okay, the selected data is a Gaussian distribution data. This is all about linear discriminant analysis. Thank you.